Hello everyone and welcome. Today we will be talking about the mole. Now this lesson corresponds to section 6.3 from your textbook. Okay, so let's go ahead, let's jump right on in. So what is the mole? Okay, now I don't need you to write this down, I just want you to kind of watch and kind of understand. I'm actually, let me build on the back side here. Okay, if I had a pair, okay, if I had a pair of anything, if I had a pair of pencils, how many pencils would I have? Well, we would say I had 2 of them. Okay, what about a dozen? If I had a dozen pencils, how many pencils would I have? Well, I would have 12 pencils. Okay, so these names here represent a number. So if I had a pair of pliers, I would have 2 pliers. If I had a pair of pencils, I would have 2 pencils. So this name pair means 2. This word dozen means 12. Now in chemistry, we're not going to be having a pair of atoms. We're not going to typically have 2 or a dozen atoms. We're going to have billions upon trillions, even more. Okay, much more actually. Okay, so what we use is something called a mole. Okay, now a mole is 6.02 times 10 to the 23. Okay, now it's a little bit different, but once again, if you know or remember your scientific notation, times, if you take 6.02 and multiply it by 10 to the power 23, what that means is you have 23 zeros essentially, okay, or 23 place values behind. Okay, this number is massive. It's a huge number. Okay, so if I said I have a mole of pencils, I would have this many pencils. If I had a mole of pliers or whatever the case is, I would have this many of that object. Okay, so whenever we say we have a mole, we have this many whatever we're talking about. So compounds, molecules, atoms, right? So if I had a mole of oxygen, I would have this many particles of oxygen. Okay, now that's kind of what this is talking about here. I don't really like how this is worded, so don't worry about this one here. You can read it if you'd like. But once again, what I'm more worried that you understand is this here. Okay, the chemistry counting unit in what we call the mole. Okay, so like I said, things in chemistry are extremely small. They don't have much mass, right? If we're talking about electrons, protons, a molecule of water, it's extremely small. Okay, now these things in chemistry, they could be an atom, right? I could have an atom of oxygen. I could have molecules of water. I could have ions of sodium 1+, right? Once again, all of these concepts can go back to the mole here. Okay, now on a formula sheet or anything like that, I'm not going to give you 6.022. I'm going to give you 6.02. So you can cross out this extra 2. Okay. Once again, in our class anyways, we're going to be dealing with mostly 2 decimal places. Okay. Unless I specify otherwise. Okay. And once again, this is what we have here. This number is what we call a mole. Okay, it's how many particles, how many things we have in one mole. Okay, now formally we call this number Avogadro's number. Now the reason why we call it Avogadro's number is because it's named after an Italian scientist whose last name was Avogadro, who came up with this concept. Now he came up with this concept because he had exactly 12 grams of carbon. And he came up with the idea that 12 grams of carbon, okay, is what he called 1 mole. And he figured that, or estimated, a really close estimation, because it's impossible to count it exactly, but he came up with a very close estimation that 12 grams of carbon, okay, and carbon is solid at room temperature, so if you had 12 grams of solid carbon, he called that 1 mole. And he said that in those 12 grams of carbon, there were this many particles. So that's why he came up with this number. Okay, so this number corresponds to having 12 grams of carbon, and we kind of keep it consistent. Now, on your formula sheet, you'll see this. N subscript A, so that stands for Avogadro's number, and you'd be given this number here. Okay, so on a test or anything like that, this is what you're going to be given. You just need to understand what it means. Okay, now that, once again, that means Avogadro's number. And the reason why we have that, it's because it's 12 grams of carbon. Okay. Now, the last thing that you need before we move on to actually getting into some questions is you need your periodic table. Okay, so please take it out, and this is the side that I'm looking at here. Okay, now on your periodic table, okay, if you look over here, there's the key, and what I'm looking for is my atomic weight. That is my mass. Okay, so let's look at carbon. So if you look at the mass of carbon, it says 12.0107 or so forth there. Okay, now what does that mean? Where did we see that number 12, especially for carbon? Well, we saw this number over here. Okay, and once again, Avogadro came up with the idea that if he had 12 grams of carbon, he called this 1 mole. So 1 mole of carbon is 12.01 or so grams. Now, what about oxygen? How much would 1 mole of oxygen weigh? Well, if you take a look at your periodic table, this number, the atomic weight, where it says 15.99 and so forth, that is the atomic mass of oxygen, also known as the mass of oxygen at 1 mole. So 1 mole of oxygen would weigh about 16 or so grams. If I had 1 mole of fluorine, it's going to weigh 18.99 grams or so. So all these numbers on the periodic table where you have your mass, what those represent, it's the mass of that compound if you had 1 mole of those particles there. So if I had 6.02 times 10 to the 23 particles of helium, I would have 1 mole of helium and it would weigh approximately 4 grams. If I had half a mole of helium, it would only weigh about 2 grams. If I had 2 times the amount of moles, it would weigh about 8 grams. Okay, so hopefully you're seeing that idea or that relationship. Okay, so that's where this point here comes from. The atomic mass on the periodic table is the mass of 1 mole of atoms of that substance. Okay, so if I had any of these weights here, corresponds to 1 mole of any of those any of those elements there. Okay, so let's actually get some questions going here, and let's see if we can figure it out. Okay, so for the first one, okay, the first thing I'm going to do is we're going to cross out silver chloride, and I want you to just put chlorine. Okay, so if we have 1 mole of silver and we have 1 mole of chlorine. Okay, so I have 1 mole of silver, 1 mole of chlorine. What do they have in common? Think about that for a second. What would they have in common if I had both 1 mole of silver and I had 1 mole of chlorine? Well, both of them, they're both going to have the same amount of particles. Okay, now how many particles are they both going to have? They're both going to have that 6.02 times 10 to the 23 particles, or things, or atoms, or molecules, or elements, right? And that's why it said things on the other side. So if we're looking at silver and we're looking at chlorine specifically, well, both of those are elements. So we would have 6.02 times 10 to the 23 elements, and that's what's both in common for both of them here. Okay, so once again, when you have a mole of silver and you have a mole of chlorine, they have the same amount of particles, elements. If I had 1 mole of pencils, I would have this many, now it wouldn't be elements anymore, but I would have this many pencils. Okay, so once again, that's the idea behind a mole. Now, which one would have the greater mass? And how do we know? So in order to do this part of the question, we need to go back to our periodic table. Now, in my class, in our class here, we are going to round everything to 2 decimals unless specified differently. Okay, so always round your final answer to 2 decimals. All your work throughout, keep as many decimals as you can, because the more you keep, the more accurate your answer will be. But your final answer should be rounded to 2 decimals. So anyways, which one would have the greater mass? So we would have to look for 1 mole of chlorine. Okay, so 1 mole of chlorine. If I look at my periodic table, so I'm going to round to 2 decimals. It's 35.453. So it's going to be 35.45. Okay, now typically we say this is in grams. Okay, so if I had 1 mole of chlorine, it's going to weigh about that. If I had 1 mole of silver, silver is Ag, silver, sorry, Ag. Once again, if I look here, silver is 107 that says, I believe it's 868. So if it's 868, it should be 87. So our mass, for silver would be 107.87, and it's about grams. Okay, so once again, I'm getting these numbers from our atomic weights of both of them. So which one would have the greater mass? Well, clearly silver. Now, how do you know? Well, yes, we can tell by here, but what's another way we can tell that which one has a greater mass? Well, you need to remember that as we move along our periodic table, each element is gaining more protons, more electrons. So yes, if we're talking about 1 chlorine compared to 1 silver, it's not going to make much of a difference having a couple extra protons or electrons, but we're talking about having this many particles. So if I have this many more protons and electrons, that's going to start to add up pretty significantly. And that's why we have such a big jump in our weights. Okay, now in this unit, we are going to be calculating molar mass. Okay, now the molar mass is the mass per 1 mole. Okay, not every single time are we going to be dealing with silver and chlorine and oxygen, but we're going to be dealing with compounds. Okay, so for example, if we look at this first question here, it says determine the molar mass of silver chloride. Okay, so what we're trying to figure out is how much would this weigh if we had 1 mole of silver chloride? Okay, I'm going to say that again because it's extremely important. If I had 1 mole of silver chloride, how much would it weigh? Okay, over here, we looked at 1 mole of chlorine, how much it would weigh. How much would it weigh in 1 mole of silver? Okay, now we're looking at how much would it weigh with silver chloride. All right, so how do we do this question? The first thing we need to do is we need to come up with the formula for silver chloride. So looking at my periodic table, okay, my silver comes first because it is a metal, and silver is a 1+ charge. Chlorine is a non-metal, it has a 1 negative charge. So when I do my crisscross, I get AgCl. Okay, so that's the formula for silver chloride. So in order to find our molar mass of silver chloride, what we're going to do is we are going to add up. Okay, I'm going to just do this. We're going to add up the mass of 1 silver, because that's what we have here, and 1 chlorine together, and that total weight should be the weight for 1 mole. Okay, so what I'm going to do, okay, so I have my mass. Well, it's called molar mass, molar mass of chlorine. Okay, so first I have 1 chlorine. So that here is going to be 35.45. Okay, and hold off from putting your units, okay, because I'm going to talk about this after. And then we're going to have the molar mass. I'm just going to do this of silver. So it's 107.87. And once again, I'm holding off for the units because we're actually going to introduce something in a second. Now, if I had 2 silvers, I would have to do this number times 2, or just add a second one. If I had 3 silvers, I would have to take this number and multiply it by 3. If I had 10 silvers, I would have to take this number and multiply it by 10. Because what we're trying to calculate is how many silvers, how many chlorines we had. So in this case, we only have 1 silver and 1 chlorine. So we only need 1 and 1. Okay, so I'm going to add these up. And what this is going to give me is the molar mass of my silver chloride. Okay, so if I add these up and I'm rounding to 2 decimals, I should have gotten 143.32. Okay, now what is my unit of measurement? Yes, we have grams. But how many moles do we have? We have 1 mole. And like I said, the molar mass is the mass you have in 1 mole. So our units of measurement when we're doing our molar mass is going to be grams per mole. And what that means is this is how much silver chloride weighs when you have 1 mole. What if I had 2 moles of silver chloride? Well, I would take this number and multiply it by 2. If I had half a mole, I would take this number and divide it by 2 or multiply it by a half. Okay, so this is the mass of silver chloride if we had 1 mole. And that's why we put grams per mole. Okay, so that is our unit of measurement. All right, what I want you to do is I want you to try the next one. Okay, it says determine the mass for sodium phosphide. So what you're going to do is you're going to come up with what the formula is and then add up what you need and get that final total mass. And once again, it's called our molar mass, so it needs to be in grams per mole. Okay, so pause the video, try it out, and see if you get the right answer. All right, so for this one here, we have determined the molar mass for sodium phosphide. So the first thing we need to do is we need to come up with sodium as phosphite. So sodium is a 1 plus, phosphorus is a 3 negative. So when I do my crisscross, I get Na3P, sodium phosphide. Okay, so in order to do this, we need the molar mass of sodium, and we need the molar mass of phosphorus. Okay, so once again, going into our periodic table, sodium, I got 22.99. Okay, and once again, our unit of measurement for all of these are grams per mole. Okay, because once again, the molar mass of sodium would weigh 22.99 grams if you had 1 mole of it. Phosphorus has 30.97, and it's also grams per mole, because that's how much it would weigh if we had that there. Now, how many sodiums do I have? I have 3 sodiums, so technically I would have 3 moles of sodium. Okay, so what we're going to do is we're going to take 22.99 here, and we're going to multiply it by 3. And the number that you get, that's what we're going to add to phosphorus. Okay, so I'm kind of running out of room here, so I'm just going to put an arrow up top. Okay, so I need 22.99. I'm going to multiply it by 3. Okay, and I got 68.97 grams per mole. Okay, so that's how much 3, okay, because we have a 3 there, 3 moles would weigh, and I only have 1 mole of this. So what we're going to do is we're going to add these 2 numbers up, and we're going to get our molar mass of sodium phosphide. and I got 99.94 grams per mole. So that's how our molar mass of sodium phosphide would be. Okay, try the last one and see if you can get this next one. Okay, so hopefully you tried it out. Once again, we have sodium, which is a 1 plus. This time we have sulfate. Okay, so sulfate is SO4 2 negative. So when we do a crisscross, we get Na2SO4. Okay, so we need 2 sodiums this time. Okay, so once again, once you start getting better at this, you don't have to write it out every single time. I'll be looking for the final answer. Okay, because once again, like I said, we're going to be using this throughout the unit. So it's just important that you're able to calculate it correctly. Okay, so we have, what I'm going to do is I'm going to do 2 times 22.99. Okay, so that's for sodium. Okay, I have 1 sulfur. Okay, so sulfur here is 32.07. Okay, so I'm going to put it over here, 32.07. Okay, so this is, I'm trying to make this as easy to follow as I can. Okay, so this here is 2 sodiums. Okay, I have 1 sulfur. And I'm going to have 4 oxygens. Okay, now for oxygen's 15.999. So rounding it to 2 decimals, it would actually be 4 times 16.00. Okay, so oxygen is 16.00 when we're rounding it to 2 decimals. Okay, so anyways, I'm getting my numbers here. So 2 sodiums, 2 times 22.99 gives me 45.98. Okay, 4 times 16 is 64.00. Keep those decimals there. And lastly, we're just going to add these all up. And when I do that, I got 142.05 grams per mole. And that is how much sodium sulfate would weigh if we had 1 mole of that there. Okay, so once again, 2 sodiums, that's why I got that. 1 sulfur, so I didn't have to multiply it by anything. And I had 4 oxygens, and so once again, 4 times that mass. Once again, that mass is 15.999, so we rounded up to 16.00. Okay, so thank you for watching, and have a great day.